Okay, part 2 of classwork 5.9. Let's first remember, if you have a polynomial over a polynomial, and your numerator polynomial and denominator polynomial have equal degrees. So, for example, let's say you have 3x squared minus 5x plus 2. And then you have 2x squared plus 6x. I'll just leave it there. Let's say this is your rational function. If your largest exponent in the numerator and your largest exponent in the denominator are the same, then when x gets really, really big, the addition or subtraction of lesser degree terms within the numerator polynomial and within the denominator polynomial are going to slowly become obsolete. And you will be heading to a ratio of the leading coefficients. So in this case, the horizontal asymptote is equal to 3/2. So it's the ratio of the leading coefficients if the degrees are the same. If the degree in the numerator is greater than the degree in the denominator, so for example, let's say your numerator is a degree 3 polynomial, your denominator is a degree 2 polynomial. Here, the degree in the numerator is greater. If that's your situation, then you aren't going to have your graph be flattening to a horizontal asymptote in the end. It will be doing a heading to infinity, kind of like the polynomials did the heads to infinity, but just not necessarily as steep as the polynomials did. So you have no horizontal asymptote in that situation. If the degree in your numerator is less than the degree in your denominator, so let's say your numerator is x plus 1 and your denominator is x squared plus 2x. The degree of your numerator polynomial is 1. The degree of your denominator polynomial is larger than that 1. It's a 2. In that case, your horizontal asymptote is y equals 0, the x-axis. And I want to point out to you again, I talked about this issue yesterday as far as if you are dealing with a large x squared and x cubed are so much larger. I want to show you with a Desmos graph a little bit more. So take a look. I have y equals x, x squared, x cubed, x to the 4th, and x to the 5th, all in different colors. And what I'm going to do is I'm going to make the y-axis shrink down because I want you to see this difference. This is a very valuable difference to notice. So I really wish that wouldn't pop up, but whatever. I'm going to delete that. And I'm going to first show you this. I want you to see how the y equals x line, and look, we're going at 1,000 here for your y values. The x values are the same x values. We've got 2, 4, 6, 8, 10, 12, 14, 16. That's not even very far along x. But I want you to see that y equals x looks like a flat line at that point. And that's because what I've done is I've taken the y-axis and gone And so we're looking at a distorted view. But with this distorted view, you can see a little bit better the effect of a large X on the actual Y values and how they are different from each other. I'm going to zoom, and the blue X squared, you can see that's, your basic parabola. But look at how much flatter that is from the higher degrees. I'm going to go further.
Wait, Miss Blanchard?
Yes.
Wouldn't y equals x not be a flat line? Wouldn't it just be, it would go through the origin, but all values of y and all values of x would be equal, but it would still be,
right.
It'd still have a slope of 1.
Yeah. And so this is distorted. And because I changed only the y maximum, I made it so the x's, over here I have x equals 16. And the y is 16 at 16. But the problem is y equals 16 is, I've got 200 right here. So 16 is way down here. So with this distortion, it makes y equals x look like a flat line. But what I want you to see is relative to the graph of x squared and the graph of x cubed, that's what infinity sees. So when you're looking at a large x value, and if you have these higher degree terms, this is how these higher degree terms view x. They view it as almost nothing. And that's what that distortion is trying to show you. And what I'm going to do is I'm going to make the distortion further. I just added another 0 on. So I really squished this down. Realize that I've got 2,000 for the y value here, but I have not changed the x's. You can now see that the x squared graph looks like it's flattening. And the x cubed graph is looking much flatter. What I'm hoping you can see, and again, this is a distortion, but it's helping you to see the power of the higher exponent and how much faster it heads to infinity than anything of lesser degree. So I'm going to go back over here and I'm going to add some more zeros in. Realize that now this y is 200,000. And I'm still dealing with x being 2468 and so on. You can see that even x to the 5th is starting to squish down. But what I want you to understand is if I am adding these together, the largest exponent is going to overtake the lesser degree exponents that are trying to add on to it. This is, if you see, we've lost track of x to the 5th as I moved over. X to the 5th is still way up there. And when it looks at x to the 4th down here, it's like, you're small. You don't affect me very much. And the lesser degree you have, the lesser it affects it. And I can continue to look over here and squish even more. If I go far enough, I can make them all look flat with the distortion. But I want you to just understand how significant a largest degree term is when you are adding lesser degree terms on. It's the issue of the addition. So like right here, if you look at the plus 2x, the polynomial in the denominator, when x gets large enough, the x squared is overcoming the effects of adding 2x to the point where it looks like adding 2x is like adding 0 relative to x squared. Now, if that makes some sense, great. If it doesn't, let it go. It's okay. It doesn't have to make full sense. But I wanted to present that in the hopes that for some of you, it'll gain some perspective on why the horizontal asymptote follows this rule. So when I look at so here are the official answers. If the numerator and denominator have equal degree, then the horizontal asymptote is the ratio of the leading coefficients. And it's the numerator polynomial divided by the denominator polynomial leading coefficients. So now let's do some work. Let's do some practice problems. Number 1. I am actually going to start with horizontal asymptote. So horizontal asymptote. Look at your numerator polynomial and your denominator polynomial. The degree of the numerator polynomial is the largest exponent, and that's a 2. It's a degree 2. The denominator, the largest exponent, is a 2. Degree 2, degree 2. If the degrees of the polynomial in the numerator and denominator are equal, then the horizontal asymptote is the ratio of the leading coefficients. And the leading coefficients are the number multiplied to the x that has that largest exponent. And so the horizontal asymptote is 9/2. And so horizontal asymptotes is the thing that's new. The rest of the questions here are things that we've been doing. If you want to know your x-intercepts are when the y is equal to 0, and f of x is the y. A fraction will only equal 0 when its numerator is equal to 0. So you need to solve this equation. 9x squared minus 4 equals 0. You have 2 options, actually 3, but your better options are either to factor this second degree polynomial and solve for the factors being equal to 0. But since you only have a single x out of the entire equation, you can also slowly isolate the x by adding 4 dividing by 9. And if you factor it, it will factor to, it's a difference of squares. So a pair of conjugate factors, one's addition, one's subtraction. And 9x squared is 3x squared. 4 is 2 squared. And you can see through that if you set each of these equal to 0, you are getting, I just wrote that in the wrong spot. You're getting your x-intercepts are plus or minus 2/3. For the vertical asymptotes, that's what makes your denominator 0. And with this, your options are factor or quadratic formula. if I go about factoring it, let me actually go through a slower factoring process this time. I'm looking at a times c is negative 20. The b number is a positive 1. I need two numbers that multiply to make negative 20 and add to make 1. And those numbers would be a positive 5 and a negative 4. So that tells me how to split up the x term. And while I am factoring this, I'm trying to get this entire polynomial inside the box. Inside the box, I start with the 2x squared in the upper left corner. The negative 10 is going to show up in the bottom right corner. And the x is going to come about as an addition of these two boxes. Let me color code a little bit. And this is telling me how to split up that addition so that the factoring will work out. So I have a positive 5x and a negative 4x will add to make this positive x. Then it's a matter of decide where you want to start because you've got 4 spots to fill. 1 spot, 2 spot, 3 spot, 4 spot. And start with any of those. And let's say I pick this spot to start with. Then I'm going to look at this row and look at what will divide both terms in that row. A 2 and an x will divide both terms in that row. So if that's a 2x, then this box has to multiply to make 2x squared, and that would be x. Then if that's an x, this has to be a 5 so that they multiply to make 5x. And this, I need 2x to multiply by something that would be negative 2. Multiplying those two will give me negative 4x, and then notice that multiplying them gives me that negative 10. So I thought I'd do a little bit of a review of factoring because I know people struggle with that. So the factoring of that denominator is x minus 2 and 2x plus 5. And from there, solving for each individual factor equal to 0. X minus 2 equaling 0 will give me a positive 2. 2x plus 5 being equal to 0 will give me a negative 5 halves. You can write that as negative 2.5 if you like. You can write it whatever way you want. What we get is that these are the answers. That's number 1. Now let's look at number 2. And again, I want to start with horizontal asymptote because that's the thing that's new. What is the degree of the numerator polynomial? And I just noticed the question, why is it only the numerator? Was that for the X-Intercepts? If that was a question, okay. So, horizontal asymptote. What is the degree of the numerator polynomial? I just highlighted it. Okay, 3. Oh, I see someone answered it already. What is the degree of the denominator polynomial? Anyone? What's the degree of the denominator polynomial? What's the largest exponent? Thank you so much. 2.
Other people said in the chat also, by the way.
Ah, thank you. So this is a situation where the numerator's degree is larger than the denominator's degree. What does that mean as the horizontal asymptote? There isn't a horizontal asymptote. So what you're going to have to do is think about the difference between whether the numerator is higher degree or the denominator is the higher degree. Because the higher degree polynomial is going to overtake the lesser degree polynomial. It will infinitely take over size to the other one. The ratio of a bigger degree that's heading to infinity infinitely faster than the bottom smaller degree means that your fraction is becoming a very large number on top compared to the number on the bottom, and that's just heading to infinity, and that's not going to give you a horizontal asymptote. That's going to give you a like disco or, heading up or heading down, but not heading out to a flat line. Then X-Intercepts, what makes the numerator equal to 0? Vertical asymptotes are what makes the denominator equal to 0. And when I don't have a number in front of my x squared, the factoring is a little bit easier. You're just looking at two numbers that multiply to make negative 28, but adding them gives you a positive 3. 7 times 4 gives me 28. If I use a positive 7 and a negative 4, I'll get negative 28, and they will add to make a positive 3. So solving for that being equal to 0, my vertical asymptotes are, and let me emphasize, you are taking each factor, setting it equal to 0, and then solving it. So I subtract 7 and I add 4, and I have my two vertical asymptotes. All right, now let's look at number 3. And again, I'm going to start with horizontal asymptote. What is the degree of the numerator? We do not have a quiz today. I did not get it prepped. I've been overly focused on AP exams, so that is fortunate for you guys, I suppose. All right, what's the degree of the numerator?
1.
Yes. What's the degree of the denominator?
2.
Yes, and I think you guys are seeing that because you were answering before in chat. So what does this mean about my horizontal asymptote? What is my horizontal asymptote? You can just type it in. What is my horizontal asymptote? 0, yes. And what you want to be aware of is with the degree 1 polynomial in the numerator and a larger degree in the denominator, the larger x gets, the ratio between the top and the bottom becomes this thing where the bottom is so much larger than the top that it's actually heading to 0. When the degree is larger in the numerator than the denominator, then the numerator is getting so large compared to the denominator that fraction is actually heading to infinity, and you do not have a horizontal asymptote. Then X-intercepts are what makes the numerator equal to 0. Vertical asymptotes are what makes the denominator equal to 0, and make sure you are very clear about which one is which. factoring the denominator, we can see that the vertical asymptotes are 4 and 2.
I'm sorry, do you mind going back up to number 2
Mm-hmm.
real quick?
Yes. Yeah. Did you?
Okay. I think. Okay. All right. I saw the -7 and 4 real quick, and I thought it was.
Yeah. And that's often what ends up mixing people up, especially if it especially messes people up if they're getting through the class through pure memorization. If you're getting through it with understanding, the visual of that is going to throw you off for a moment, but then you're going to look at it more and realize and understand. But if you're getting through the class through memorization, you need to be extra careful. You're having to factor it, but then solve each factor being equal to 0. And it's when you solve the factors equaling to 0 that you end up with these opposite signs.
Yeah, thanks.
Yeah, no problem. But I wanted to also clarify that for people who I know have an issue with that. When you first look at it, it can throw you off, but I know some people are very confused about it every time they do a test. All right, so that's number 3. Number 4. First, horizontal asymptotes. Are the degree of the numerator and denominator the same?
Yeah.
Mm-hmm. That means that it's a ratio of the leading coefficients. So what I'm going to do is highlight the entire leading term. If you actually just took the leading terms and wrote them down and simplified, you would get the horizontal asymptote. And the leading coefficients, if there's nothing written, those are 1s. So 1 divided by 1 gives you 1, and that is your horizontal asymptote. Then the other two things are X-intercept, what makes the numerator equal to 0. If I factor, I'm looking for two numbers that multiply to make 24, positive 24, but when I add them, I get a positive 10. 6 and 4 come to mind. But when you're solving for it equal to 0, you're looking at what you plug into X to make that factor equal 0. For the vertical asymptotes, what makes the denominator equal to 0? And you should see either by factoring or by adding 25 to the other side that it's plus or minus 5. Now, we are at the end of what I expect you to be able to do when you draw a graph. So know that there's going to be a difference of you being able to multiple choice select or matching with graphs and equations. And then there is you actually drawing the graph. If you have to actually draw the graph, there's only so much I'm going to expect of you for that, and I want you to be clear. So this is what I want you to be clear on. First, find the things that are asked for. So, can't get it to... Why are you being annoying? Because I can. Okay, so X-intercepts. What makes the numerator equal to 0? We're going to have to factor. And if you like, I'll go through a slower factoring, but not too slow. 2 times 4 is 8. Middle term is 9. They're all positive. Numbers that multiply to make 8 add to make 9, that would be 8 and 1. So that tells me how to box this up. I'll put the box here for right now. No, that's not going to work. I'll put the box up here. So I have to have 2x squared the constant, and then the x term is split up 8x and 1x. And then if I decide to start with this spot, I'm looking at what are two numbers, or not, no, sorry, back up. What will divide both of these? Just x. Then x times 2x will give me 2x squared. And then 2x times 4 will give me 8x. I've got one of my factors. For the other factor, x, I just need a 1 here. X times 1 and 4 times 1 will give me that second column. So 2x plus 1 is my other factor. And solving for those being equal to 0, I'm getting negative 4 and a negative 1/2. Okay, vertical asymptote. For vertical asymptote, I'm looking at what makes the denominator equal to 0. So I have x minus 5 and x plus 2 when I factor. And that means my vertical asymptotes are 5 and negative 2. And then horizontal asymptote, the newbie. Do the degrees match on the polynomial, on the two polynomials? And you say, yes, yes they do. What are the leading coefficients? What is the horizontal asymptote? Somebody type in the horizontal asymptote. Yes, thank you. Y equals 2. So this is all the information that is asked for. The information that is asked for needs to be drawn. So I'm going to draw my, or I'm going to plot my x-intercepts, negative 4 and negative 1/2. I have vertical asymptotes, 2 of them. One is at positive 5. I'm going to draw my vertical asymptote. The other is negative 2. And I want to extend those to the edge. And then I have horizontal asymptote as y equals 2. And I draw that. If you don't, it is your choice if you want to make a number line and figure out the positive, negative issues, or if you want to plot points. As we are at the end of this, I want you to decide how you're going to go about finding this and determining what's going on with these asymptotes. So one way of doing that is you can make a number line for this function, a sign line. Anything that is an x-intercept or a vertical asymptote, put those on the number line in order. I have 4 numbers. Negative 4 is the smallest. Negative 2 is the next up. Negative 1/2 is the next step. And 5 is the next step. If I were to write this function in factored form, the numerator factored to x plus 4 times 2x plus 1, the denominator factored to x minus 5x plus 2. I want you to notice that each of those is a linear factor. It's just x to the 1 power in each parentheses. And none of them have exponents. All of them have an understood 1 exponent on each of these linear factors. If that is your situation, it will go back and forth between positive and negative. All you have to do is figure out one section, is it positive or negative? What I will usually do is I will look at x equals 10 because it's usually bigger than anything else. And I will look at these factors. I'm going to erase this. Okay. If I plug in positive 10 plus 4 is positive. Positive 10, definitely 2x plus 1 will be positive. 10 minus 5 is still positive. 10 plus 2 is positive. This section is definitely positive. Now, because I don't have any parentheses squared or parentheses to the 4th power, this will go back and forth. You can double check it, but I will tell you that if you recognize this, it'll go faster. Then, bringing this together, and I'm going to color code, you have a positive value if you are dealing with smaller than negative 4. The horizontal asymptote not being 0 makes this slightly more challenging, but the question is how much work do you want to put in to figure out what the graph is doing? Because the tedious work I've been having you do is cumbersome, and you probably don't want to do it. Now, between negative 4 and negative 2, I know that my y values are negative, so I'm existing down here. Then from negative 2 to negative 1/2, I know that I have positive y values. I'm going to try and line that up. And let's go to, okay, hold on. There we go. Next section, under the x-axis, negative y values from negative 1/2 until 5. And then one more section to go. This section shows that if my x is larger than 5, I have only positive values. And now I'm going to tell you what you can know and what you're not sure of with this information. Each asymptote has 2 places to look. The horizontal asymptote has a left end and a right end. It's actually a good thing I don't have a quiz today because I need to finish this. So I'm going to get rid of some of this excess just because it's in the way a bit of what I'm showing you. highlight that again. Okay. My asymptote has a left end and a right end. On the left end, it's either above the horizontal asymptote or below. Based on what I've found, I'm not sure which one it is. On the right end, it's either coming from above or below. And again, based on the information I have, I don't know which one it is. To be sure which one it is, you would need to go through a long algebra process that you're not likely to want to do anyway. So I'm going to leave those two things there, and I'm going to move on to the vertical asymptotes, because the vertical asymptotes are actually really easy to work out with this positive negative knowledge. Two vertical asymptotes. First, vertical asymptote of -2. It has a left side and a right side. On the left side, it's either going up or down. On the right side, it's either going up or down. And because of knowing where it's positive and negative, that's right there. Vertical asymptote at 5 has a left side and a right side. You know exactly what they're going to be based on what you have found. Now, what do you know for sure? The left and right ends, I'm not sure about. But all the highlights in the middle, the blue highlight, I know that my graph is essentially going from this x-intercept and heading down. I know that in the green, I am coming down from this vertical asymptote and heading to this x-intercept. How it curves, not exactly sure. In the pink region, I know I'm coming from this x-intercept and I'm going to head down this asymptote. How much does it curve? I'm not sure. Now, I do know this vertical asymptote. I do know that I'm in the yellow section. I've got this x-intercept that I have to head to. Now, listen very carefully about what I'm expecting. I do not expect you to be entirely sure whether you are above or below the horizontal asymptote. Just showed that it's basically heading toward it, and that is enough. Because the amount of work that is required to be fully aware of which side of the asymptote you are on tends to not really be worth it if you're just trying to get a rough sketch. And at this level of math, I'm wanting you to just get a rough sketch idea. You will get more details about graphing rational functions if you go into the Intro to Calculus class. This right here is as far as I expect you to leave the class understanding. So realize how much I'm not expecting you to get completely right. But what is expected? Make sure that that you find these 3 items. You can find a y-intercept, but it's usually just some horrible fraction. The number line is incredibly helpful. I would recommend it. My recommendation is find these 3 things off of the x-intercepts and the vertical asymptotes. Make a sign chart To find the x-intercepts and the vertical asymptotes, you already had to factor your numerator and denominator. Take a moment to notice whether those factors have a squared on them or if they're all just an understood one exponent, because that will save you the time of having to sit there and plug a number in for each of these intervals. If you do see an even exponent, take caution. And for some of you, it may be a better idea to just stick to check a number in each interval. If you get the idea, then when you see a factor, if you have a factor that has an even exponent. Now I'm going to make something up, so I'm getting away from the graph. Let's say you have x plus 1 squared is either in the numerator or the denominator, one or the other. -1 makes that equal to 0. So when you look at that spot on the number line, when you do the signs with the pluses and the minuses, you might have some other numbers. But at this 0, you will not get a sign change. The two sides are the same. They're either both positive or both negative. Other than that, this sign line is going to switch back and forth, positive, negative, positive, negative. As long as you write down every x-intercept and vertical asymptote and pay attention to any squared factors. And that is good enough. On the answer key, I explain a little bit more about the fact that you have two options really for each horizontal asymptote, that it's doing one or the other. I don't expect you to know that. I want you to just kind of draw something that kind of does it and notice that it's heading to the asymptote, and that is good enough. I'm hoping you're clear on the expectations. And this is the alternative that you probably don't want. This is excessive. But I wanted to present to you how you can do it if you want to put in more time. And this is then the graph, how it should look. This is how it actually looks. You just need to be close to that. You don't have to be getting exactly that. Then I wrote this here for you guys. This is what I expect. I want you to realize that you should be able to find x-intercepts, vertical asymptotes, horizontal asymptotes, and I'm not going to push it, but I will tell you that this is extremely helpful. What am I going to ask you to graph on the test? I'm not going to expect you to graph anything with no horizontal asymptote. You will deal more with that in your next math class. So I'm only going to have you graph if you have a horizontal asymptote. You don't even need to necessarily, with a non-zero horizontal asymptote, you can determine, but you don't have to. Just follow the horizontal asymptote. Know that I will only ask you to graph rational functions with numerator and denominator polynomials. that can be factored into linear factors. And I still expect you to be able to determine some graphical information from rational functions that you are not expected to graph in full. In other words, multiple choice, be able to do the multiple choice, and I'll give you a practice test later to help you see, or matching. And it looks like people are leaving, and I'm guessing that's because class is over. Is that correct? Class is over?
Are you posting this on Google Classroom?
What?
Are you going to be posting this on Google Classroom?
Yes. Yeah. And I'm going to stop the video now.